Okay, good morning. So let us start with those two problems. If you remember, what was the? So I asked you to write an equation for the plane that contains these two lines. Yes. So this has two parts, if you remember. But what was my intention, it becomes clear. So I have a line L. I don't remember exactly what I called it when I was writing it, but hopefully the equation was x equals to y equals to z. And then I had another line L prime, and then equation was given to be x equals to 2y equals to 3z. So hopefully whenever you see these equations, you should immediately understand they are expressing lines in space, yes? They are canonical forms, but not in a standard form, of course. So the question is that, can you write an equation for the plane that contains these two lines? Yes. And this is part one of the problem. The second part, I am asking you the same question, but I have changed the equation of my lines to these equations. I have kept this one exactly the same, and then I have changed L prime to 2x is equal to 2y is equal to 2z plus 1. The same problem. Again, I'm asking you to write an equation for the plane that contains an L prime. I want you to tell me why I have set up two problems with different numbers with the same subject or topic. So why do you think is that? And what would be the difference between these two cases? So let us concentrate on the first one here. So how can I do that? First of all, let us concentrate on number one. If I'm asking to write an equation for the plane that contains an L and L prime, so the responsibility is on me that these two lines shouldn't be skew symmetric. Skew parallel, yes, because if they are skew parallel, then there is no hope, yes, there are no plane containing both of them, yes. So when I'm asking you this question, apparently this is the case. But there are three other scenarios. Either they overlap exactly, but they don't. You can feel that they are not the same. But then there are two other scenarios. Either they are intersecting, then they form a plane, that's correct, and they might be parallel, and then in that case they also form a plane. So that's why I have given you two questions. One of them is for this case, the other one is for this case. But I want you to see how can you solve the problem. Can you find an equation for the plane? And which one is which? Can you immediately understand? Is this the intersecting part, is the intersecting case, or this one is the intersecting case? One of them should be the parallel case, and one of them should be the intersecting case. Which one is which, do you know?
It feels like the first one is the intersection.
Intersecting one, why?
Because the second one is the parallel, and that's because the plus one of the coefficients are.
Yeah, exactly. So this, if I ask you, this is immediately important for you to be able to read the components of a direction vector by looking at the equation. Yes. So if this is a canonical equation, if I want to read a direction vector of this, so I will say direction vector for L. This is canonical. And it is a standard. Standard, I mean that the coefficients of x and y is 0, 1. So I just read the denominators. So this 1, yes. And I want to do the same thing for L prime. So I would say that dL prime is what? I have to make, this is canonical but not standard. So what I have to do, I have to make the coefficients equal to 1. This is already 1, so the denominator is also 1. But what can I do here? I can write it as 1. I divide everything by 2. The denominator is 1. It becomes 1/2. And then the same thing here. I divide by 3. The denominator becomes a third. So if I ask you what is dl prime, you can tell me it's 1, 1/2, and a third. Yes. But are these two d and these two d's are parallel? No, because 1 is just the same 1. So this is not a multiple of the other one. So this means that dl and dl prime are not parallel. And by the way, because working with fractions is a little bit annoying, I can rescale it, because what matters for a direction vector is its direction. It's along which line is it. So I would say that, okay, I will rescale it, and then I would say I have to change the name as well. So let me just write it as, I don't know, d of l prime. I multiply everything by 6 because I want to get rid of fractions. But you need to understand the logic why we are allowed to multiply by a number. Yes? So, okay. Now we see that these two vectors are non-parallel, so it means that these two lines cannot be parallel, because if they are parallel, the direction vectors should be parallel, okay? So then you can go to a scratch paper, or even in the problem itself, you just sketch something for yourself. This is the plane, my question mark, and then I have a line, and I have another line. But of course, be careful. At this moment, I didn't explore that they are not skew parallel. I just put it on the designer of the problem. So if you're asking me this question, it should be a reasonable question, yes? So, but at least I realized that this is not the parallel case. Okay, now I know this line L, I know this line L prime. Whatever I need, I know about them. But I'm writing an equation for the plane. Okay, now can you tell me what to do? Because for writing an equation for the plane, what do I need? I need 1 point on the plane and the normal vector. So what can I do now?
To get the point, you just equate them and take the intersection.
No, don't make it hard. Because you are finding the best point. There is no best point. Of course you can find the intersection point, but why we should bother? We just need 1 point. So if I take a random point on L prime or a random point on L, it will serve the purpose, yes? So that's easier rather than trying to find exactly that point. No. So what I do, and then I hope that you agree 0, 0, 0 is the best one. Because 0, 0, 0 satisfies L. Of course, that is exactly your point, because also satisfies this one, yes? So, in this case, even though we did it randomly, but we just got your point, yes? But I mean that you really don't need to find the best point. There is no best point, yes? So I just take a random point on L, and I hope that you agree that the random point of L is 0, 0, 0. And then, okay, so for the point, I don't have any problems. But for the normal vector, what should I do? Because if this is L, dl is on it, somewhere here, or parallel to it, doesn't matter, and dl prime is somewhere here. So what should I do then? I want to find a normal vector. Cross product. So that's a very standard problem, yes? So you say that, okay, the normal vector that I am looking is equal to what? Is equal to the cross product of dl and dl prime. So then this means that I write this on top and I write this on the bottom. Okay, and then cross product them. So when I cross product them, I keep this is 2 minus 3 minus 1. I put a negative sign for the middle one. It is 2 minus 6 minus 4, so it becomes positive 4. And then finally 3 minus 6 is negative 3. So that is your normal vector. And then you take your normal vector and this point and put it in this famous equation of a plane, yes? Bad timing.
Yeah. Sorry about that.
Yeah, no worries. Okay, so here, and then instead of a and b and c, we have minus 1x minus 0 plus 4y minus 0 plus, minus 3z minus 0 equals to 0, then I will get this equation. So it becomes minus x plus 4y plus 3z equals to 0. Yeah, is that clear? So now I really want you to do the second one yourself, okay? So you should be able to do that. So do all the calculations needed for the second one. Yeah, you see here, this was minus, so this last one is also a minus sign. That's correct. Okay, what happened?
Yeah.
No idea?
We have an idea, but
Yes.
we don't know if it's working.
So let me just draw, because first of all, let me just write these d's that everyone knows what's going on. The d of L is as before, yes, is 1, 1, 1. But can you just tell me what is d of L prime?
1 over 2.
Yeah, so you have to make it in the standard form. So it's x over 1 over 2, y over 1 over 2. This one I have to divide everything by 2. It becomes z plus 1/2 this.
Yeah.
Yes? So it is 1 over 2, 1 over 2, 1 over 2. But if I rescale it as before to get rid of fractions, then I can call it, for example, dl prime. And then I can write it as 1, 1, 1. But they are actually indeed the same. So this means that dl, this means that L is parallel to L prime. Okay, then what?
So we wanted we can't cross product the two.
Yeah,
two
so let me
parallel
just draw the
vectors.
picture for you. So this is the plane that you are supposed to find, but unfortunately this time, these two lines are supposed to be on the plane. So one of them is L, one of them is L prime. Even if I find this one cross product, then it becomes the zero vector, which is useless.
So we were thinking, how can we get a vector that's still on the plane,
Exactly.
but not parallel? And
Yeah.
then we thought that maybe we can choose one point on L and one point on L prime.
That's correct. That's it. Very simple stretch. Thank you. So you have DL. So DL is good. You have it here, for example. So you can choose whatever you want, a random point here, and a random point here. You really don't have any limitations. Even if it's exactly on top, it just still works, yes? So you don't need to be worried about that. So you just take a random point here, you take a random point there, and when you connect them, it becomes a vector, which is definitely not parallel to the previous vector, but still, as you said, is on the plane. And then if I cross product them, it serves me as the normal vector, yes? So what we can do, let us just do it quickly. So for A, I go and find a random point here, which I believe it is better to call it 0, 0, 0 again. But I also need a random point B on L prime. So what is the L prime? I don't know. Let me just put x equal to 0. If I put x equal to 0, then I have to calculate everything. So y becomes 0, but z becomes minus 1/2. For example, I don't know, you can choose whatever you like, but am I allowed to rescale it to get rid of fraction? No, because the points cannot be rescaled. If you rescale them, they will move somewhere else, okay? And then you need AB. And AB is also very simple. The final point minus the initial point, so it becomes 0, 0, minus 1/2 again. And then what you need to do, N is your AB, for example, cross product by DL. AB is 0, 0, minus 1/2. DL is 1, 1, 1. You cross product them 0 plus 1/2. And then you put a minus sign here, 0 plus 1/2, what becomes minus 1/2. And then finally 0. Yes? Can I rescale this one? The answer is yes, because that's a normal vector, so I will work with a new normal vector, so let me call it n, for example. It becomes 1, minus 1, and 0. And then I can write the equation of my plane. It doesn't matter in principle if you are using point B or if you are using point A, because I need just one point. And let me just use 0, yeah? So this becomes 1. The answer will be the same at the end. So it becomes 1 x minus 0 minus 1 y minus 0, 0 z minus 0. So then if you simplify it, it's just simply x minus y equals to 0. That's the equation of your plane. Yes? Is that clear? Okay, and hope that you understand that this is a plane because we are working in 3 dimensions, yes? Okay, so let us now ask you another question. Which one probably? I think it's a good idea because we were talking about, this is by the way called the relative position of two lines. So we have two objects we have studied, planes and lines, yes? We can investigate what is the relative positions of two given planes, what is the relative positions of two given lines, and what is the relative position of one line and one plane. So these are the whole scenarios that we can have. So let us go back to the case, to the previous case. So how many relative positions you can imagine for two planes in space? Yes. Either they lie on each other, yes, so that's essentially the same, or they are parallel, or they intersect. But if they intersect not just at single point, suddenly they intersect in a line. So can you tell me, if I give you the equations of two planes, how do you recognize which one is the case for those given planes? A systematic way to understand that, yes? So for example, I don't know, I don't know if I have proper questions here, but let us just, I give you two planes, let me just write them generically. So by plus cz plus d, I give you this equation of a plane, I give you another equation for another plane, yes? Or maybe the same plane, we don't know. How can you understand that what is the relative positions of these two planes with respect to each other? What do you do the first? What do you first do? Huh?
If they lie on each other, then A should be a multiple of A prime. B should be a multiple of B prime. C should be a multiple of C prime.
Yes.
And the D value should be the same.
Yes.
Yes.
Yeah.
And if they're parallel.
But is that possible?
I don't know.
Okay, if they are parallel, what?
Maybe the D value can vary.
Okay, so you are mainly saying that if two planes are the same, so one of them is a multiple of the other one. So in that case, every coefficient should be a multiple of the other coefficient, including d. Yes, because when you divide or you multiply, you should go from one to the other one. But I don't want to look at it algebraically. Can you see it geometrically? Geometrically is better. So what you compare are the normal vectors first. So what happens, so I take the normal vector of this one, which is A, B, and C, and I take the normal vector of that one, which is A prime, B prime, C prime. And then I investigate if they are parallel or not. This shouldn't be hard. Okay, if they are not parallel, what can I conclude immediately? So let me call this P, let me call this P prime. If N is not parallel to N prime, what can you conclude?
They intersect.
P intersects P prime. Okay, but another scenario is that N turns out to be parallel to N prime. Then you have two scenarios. Either they are exactly the same, or they are really parallel but not the same. How can I recognize these two scenarios from each other? It's not very hard, because you take a random point on one of these planes and check it in the equation of the second one. If it doesn't work, it means that they are parallel, not equal. And if it turns out to be there, it means that because you have to be careful. This method does not work if you haven't already checked this step. Because what I'm saying is that first you check n and n prime. If they are not parallel, so it means that they are intersecting. So you don't go to the second step. But if they are not, if they are parallel, you go to the second step. So when they are parallel, it means that either you have this situation or they are on top of each other. So 1 point will be enough. But if you start with the second step, it is wrong. Be careful. So you have to do this one first and this one second. Let me just write step 1, step 2, okay? So that's easy, yes? So you just take a random point from one of them and check it in the other one. If it works, it means that they are actually the same planes, and if it doesn't work, it means that they have to be parallel. Okay? Is that clear? Okay, so that is regarding two lines. Sorry, that is regarding 2 planes. We partially answered about 2 lines. Let us just formalize it. Now let me give you 2 lines. And I ask you the same questions, but let me don't write the equations. So I have 2 lines L and L prime. For planes, there are 3 scenarios that might happen, but for lines, there are 4 scenarios, yes? Either they are overlapping completely, or they are not having any common points, but they lie on the same plane, so in that case they are parallel, or they are actually not having an intersection point, but they cannot lie in the same plane, so they are skew parallel. And then on the other hand, they might be, so there are 4 scenarios. Yes, how can you recognize which one is which if I give you 2 random lines by their equation? So systematically again. So how do you do that? How do you do it?
You compare the direction vectors.
That is probably a very natural step. So you take the direction vectors. In principle, you should be able to read it in any case. So, and then you compare them. So what you do, you calculate, you determine direction vector of L and the direction vector of L prime. So you read these 2 from the equations. And then you check if they are parallel or not. So there are 2 scenarios going on. Or either these 2 vectors are parallel or not parallel. Okay? So there are 2 possibilities. Either dl is parallel to dl prime, or dl is not parallel to dl prime. Yes? Yes? Okay. Then what? For this one, how many possibilities might be there if dl turns out to be parallel to dl prime? 2, yes? Because they might be exactly the same lines, or they might be parallel, yes? So this means that there are 2 scenarios. Either L is exactly equal to L prime, or L is parallel to L prime, but not equal to it. Yes. But how can I recognize which one is which if this happens? Again, the same technique, yes? I take one random point from one and check it into the other one. If it works, it means that they are the same, and if it doesn't work, it means they are parallel. Because parallelness of the direction vectors only guarantees either one of these 2. Okay? So is that clear? I didn't write it, but I just expressed that. And then, if that is happening, that is also I want you to know. If DL is not parallel to DL prime, you cannot immediately conclude, okay, they are intersecting. No, because in the case of skew parallel lines, the direction vectors are not parallel, but they are not intersecting. The lines are not intersecting. So it means that either L intersects L prime, or L and L prime are skew symmetric. Sorry, I don't know, I was teaching something else. This skew symmetric is in mine. Okay, so L and L prime are skew parallel. So how can I recognize then between these two? Yes?
I don't know if there's a more effective way, but you could always equate them. And then if you don't get an intersection, they are skew parallel.
Technically it's right, but let us see on the algebraic level and practical point how it works, okay? So let me see if I can give you examples. So if you wait a little bit so that I can find the right example. Okay, so I think this is a good example as you mentioned. So let me see. By the way, that is also another question. Another interesting question is that in the case that they intersect, an interesting question is that what are the coordinates of the intersection? Yes, that's also good to be able to answer. Okay, so let me write some equations. So it needs a little bit of care here. We have to be careful, so make sure that you really know what to do practically. So I will give you this equation. So I give you line L. Okay, I have written it x minus 3 divided by 2. Because I have to really write these numbers exactly. Y minus 5 divided by minus 3, and this is equal to z minus 1. This is one of the equations. Another one, L prime, is x minus 5 over minus 2, and the other one is y over 5, and the other one is z plus 2 over 3. So we want to realize which one is which. So we want to determine the relative positions of these two lines. Okay. So this is a standard, canonical standard form. So we can immediately read DL. What is DL? This is canonical and a standard. So it is just 2 minus 3 and 1. What is DL prime? This is minus 2, 5, and 3, yes? Are they parallel? No, because if I want to make 2 to minus 2, I have to multiply this by negative 1, but when I multiply it by negative 1, it turns out to be 3, not 5, yes? So this means that these are not parallel. DL is not parallel to DL prime. Yes, so it means that I have two scenarios going on. Either L intersects L prime, or L and L prime are skew parallel. This is we know. But we want to go further to see if this is the case or that is the case. And if the first one is the case, I want to also find the intersection point. Okay? So now, now I'm waiting you because you told me that we equate them. So I just want to understand, how do you do it algebraically? Yes, you are right. In principle, if you want to find the intersection point of any two shapes, you have to open a system and put the equations then and try to solve them, yes? But of course, this is a little bit different from usual scenarios. You have two equations involved here for one line, you have two equations here in one line. So how do you do it in practice? So which one do you want to equate, you know? Because if there is an intersection point, it means that you have one point whose coordinates satisfies all these equations and all these equations simultaneously. Yes?
But if you just make all of them equal to each other, and then you decide a value for the first one, the rest of it should solve itself.
Okay, so now let us investigate before going on. Yes, you are right. In principle, if I want to equate them, I can equate all of them. But let us see how many unknowns I have. How many unknowns I have? I'm looking for that intersection point. X coordinate, Y coordinate, Z coordinate. I have 3 unknowns. But how many equations are involved in the first one? 2. And how many equations are involved in the second one? 2. I have 4 information. So I'm lucky or unlucky. Because I need 3 unknowns, but suddenly I have 4 equations. Be careful, if you have 4 equations and less unknowns, you are still in trouble. Don't think it's a good thing. Why? Because you only need 3 of them to determine usually the 3 unknowns. Then it means that you have to be careful that the last one is also satisfied. And that is not under your control. And that is why we have 2 scenarios. Otherwise, just imagine, it doesn't matter how I write these, you can always equate them and get a number at the end. And then you might say that, okay, I proved that all lines are intersecting. Everything is a rumor. Yes, 2 lines are always intersecting because I was able to find all the time the numbers. Yes, is that understandable what I mean? So you have, because this system, the number of pieces of information you have is more than the number of unknowns. Still you are in trouble because you only need 3 of them to adjust X, Y, and Z. But the numbers that you get, that is not under your control anymore. You have to check these 3 numbers into the last constraint to see if that's satisfied or not. If it is satisfied, yes, they are intersecting. If that's not satisfied, then there is only one option left. You have to admit that they are skew parallel. So I mean the logic, you need to understand the logic. But let us do it practically now. Okay, we want to really understand how is it going. So let me just try to clean this. Okay, so what you do, you actually equate all of them. So what you say, I don't know how do you want to do it practically. So it means that, by the way, I made a mistake. We cannot equate all of them, can we? Yes, we can, yes, because we want to have them the same point, yes. You are right, but let us see how it goes. Okay, so if I equate all of them, this is not the way that I have written, but I just want to follow yours, okay? So this is y minus 5 is minus 3 is z minus 1 is equal to x minus 5 divided by minus 2 is equal to y over 5 is equal to no, because I want to understand the logic, you know, is that right?
It becomes hard.
No, I mean, no, sorry. No, we cannot equate all of them. We cannot equate all of them. What we want to do, we want to solve a system. The first equation is that. This is different from equating them, yes? Okay, so I have to correct myself, okay? Your idea is correct. And that's essentially, this is the only thing we can do. No, but be careful. We cannot put all of them equal. So it is really important to understand. What we don't put them equal to each other, but we have to open a system and put equation on one of them as one equation and this equation of the other one, and then try to solve the system. So there is no reason that I put these equal to that. Yes?
The denominator should be 3.
Where?
The last.
Thank you very much. So I was also lost. Yes, when you said that I put all of them equal, I thought that that's correct. But if you think, for example, let me just make it understand. So I give you two functions. I don't know, f of x, y equals to x squared, just in normal mathematics, two dimensions. And I give you y equals to 2x plus y. And I ask you to find the intersection point of these two functions. So what do? You equate them here because the left-hand sides are y. That's a coincidence, yes? Because of course, you have to open a system, write the first equation and write the second equation and try to solve the system. But because the left-hand sides are the same y's, you equate them. That is also true. This x is this x. That y is also this y. That z is also this z. But there is no reason that I can put this one equal to that one. Yes? But still what I told is correct. How many equations you get from here? 2 equalities, 2 equations, 2 equalities, 2 equations. In total you have 4 equations. And you have 3 unknowns. Yes? So it means that this system is overdetermined. You have more number of information than you have unknowns. And you have to still be careful. You shouldn't be very happy, okay, I have a lot of information but not that many unknowns. No. You solve it, find 3 of them. So it means that you have 1, 2, 3, 4 equations. Momentarily you ignore one of them, whichever you like, and try to solve system of 3 equations in 3 unknowns and you get your numbers. But then you need to check the numbers that you get satisfies the last one. If it satisfies, then you have succeeded to find a solution for the whole system. But if it doesn't satisfy, it means there are no such solutions that you are looking for. You have to give up. The give up geometrically means that this is the case. Is that understandable? So that is the logic. It was a little bit convoluted. Even I was confused. We shouldn't put all of them equal to each other. What we have to do is this. Okay, so then how we have to deal with the system now?
Just remove one of the variables. Which one you want to, doesn't
By
matter.
remove it, so you need to tell me exactly what to do.
uh,
Remove what?
For example, we can ignore x to begin with. So x in both equations. And then we have 2 equations and 2 unknowns for y and z.
Yes,
And then we solve that.
exactly. So it means that momentarily you don't use this piece of information. You just take this one between y and z, take this one between y and z, whichever is simpler probably is better. And then you solve it and you find x and y. It's the y and z. And then what? Assume that I know y and z in my hand. Then what should I do?
And then we compare it with one of the equations for x to find x.
X.
And then we need to compare it with the last.
If it works, it has convinced.
Yeah.
So is the strategy clear? So let us just do it quickly. So I will follow. So do you think it's better to take this one and this one? Yes. So what I write a new system. So I write y. So let us do it in our head. I multiply by -3, move it to the other side. It becomes positive 3z. Yes, or I don't know what. So let me just keep y. So I multiply -3z. And this becomes positive 3. And then -5 moves there, it becomes positive 8. And here, y becomes what? 5 over 3z plus 10 over 3. Yes? I just multiply it by 5. And then I have two y's, I can equate them, because that's the same y, that's important. So this means that I will have 5 over 3z plus 10 over 3 is equal to minus 3 plus 8. And then to get rid of fractions, I multiply by 3. And I move it here. And z is 1. Yes? And then I put it in one of these equations. It doesn't matter, they give you the same answer, but it is easier to put it here. So y becomes what? 5. Yes? And then I will take it and put it in what? And by the way, for finding x is even z, 1 is enough. So what is x? I put z here, and I get what? 3, yes? Because if I put 1 here, this becomes 0, this fraction becomes 0 if x is equal to 3. But it is not guaranteed that this satisfies all the equations. I have to check it in the equation that I haven't used so far. Yes, I use this equation to find x, and simultaneously these equations to find y and z. The only thing that I haven't checked so far is the last one. Is the last one works? If I put 3 here, it becomes minus 2 divided by minus 2 equals to, if I put 5 here, yes, it works, yes? So it works. So it means that this is the solution. So which one is the case, this one or that one? They intersect. And not only they intersect, if I ask you what is the intersection point, you can answer. What is the intersection point? 3, 5, and 1. Is that clear? But that's a good problem because it involves your geometrical visualization and algebra. Even I was confused. I wanted to equate all of them. But that's not working. Yes.
So whenever we don't find the solution, we conclude skew parallel.
Yes, but it depends. You have to do this one first to guarantee that one of them is the case, and this will recognize which one is indeed the case. Is that clear? So let me give you another problem of this type, not of this exact type. I want to give two equations here for you, and then I ask what is the relative position of these two lines. But let me write another one for you. So L is I can give you parametric form. Parametric form, yes. So this is 3t minus 1. Y is equal to minus 2t minus 3. And then z is minus t plus 2. Of course, always means t belongs to R. T can be any number. X, I intentionally write it in this way because I want to draw your attention to one point that might be confusing you. So I have given you two lines. The question is still the same. I want to find the relative position of these two lines. Okay, before you start, technically there is something wrong when I have written. What is that something wrong here? Yes?
6 equations and 5 unknowns.
No, that is a practical problem. By the way, it cannot be wrong. These are two lines, do you agree? These are two parametric forms of two lines. And there is nothing wrong with the lines. Either that's not on them, but they either control, they intersect, they don't, they are skew parallel, they are not. That is not something wrong. But technically, when I write it here, if you respect the mathematics rule, I don't know, the laws of mathematics, you shouldn't write it in that way. Yes?
Maybe it is because you use, you don't, you say x, y, and z, and then x, y, and z.
No, that's not the problem. the wrong thing about writing these two equations in this form, do you want to say something? Is because when I write t for the parameter of L prime and write the same t for the parameter of L, this is not legal. Yes? It means that if I choose t0 for this, then it means t is also 0 for that, but there is no guarantee as t is a free parameter. So t is the parameter of the line that can move freely among the real numbers, and t I am just pretending to be free parameter for this one as well, but I'm using the same letter t for this and that. This is somehow common in writing these things, but if you want to be very careful, you have to change the name of the second parameter. If you use the same letter, it means you have already decided the parameters are the same. But if you choose different letters, it might be still the case that for some cases parameters match, but that is something else. But when you write the same letter, it means that you are forcing whatever is that number, this number should be the same. So this is why even some books you see when they say 2 lines, they write it in this way. Even if they write 10 lines, they write it in this way. But you need to realize you really have to change the letter if you want to do something with them simultaneously. If you just want to consider this one, that's okay. If you just want to consider this one, that's okay. But if you want to do something relative to each other, then if you have t and t, you will run into trouble. Yes? Is that clear? So this is why, even if this is given to you in this form, okay, when you want to do something with both of them simultaneously, you need to change the other one, for example, to t prime. Yes? This is something that I wanted you to know. Otherwise, I could have written it in this form in the beginning. Okay? I have seen many books write like this without changing the parameter. But don't do that. Of course, if this is part A of a problem, this is part B, no problems. But if you want to consider them in the same problem, it's important to realize that they are not 100% equal. They might not be. Okay, now I want to wait for you. And I want you to recognize what is the relative position, what is the situation of these two lines with respect to each other. Did you get any answers? Not yet. So at least you feel that in 3 dimensions, lines are a little bit harder than what you used to. But I want you to work on this problem for tomorrow. So tomorrow I will start with this one, then I will continue to some more interesting problems. Yes. Thank you.
Ja, det ska jag göra.